very much.
You.
Our evaluations are just about to be finished. I think they will be published in October, November. So we are like 4 universities involved in this evaluation. So I can only speak for myself, but I think that most of us are done with the largest parts. So what I will present is a part of the Swedish evaluation from the team that I'm leading from Jönköping University. And we had responsibility for evaluating a lot of different measures, both in the Axis 1 and also in Axis 3. So I have to delimit and only present the results from one of these, but we use comparable methods throughout our evaluations. So this will be an example of how we did it. Let's see. Okay, so these are the main points that I will address, starting with the context of the evaluation, just very briefly describing who are we, the researchers that were involved in my team. I will also talk about the methods and some of the challenges that we tried to address and try to solve, because there are a lot of challenges, as you know, in these type of evaluations. And then continuing with the findings and so forth. So the context of the evaluation, as I said, we were 4 different universities in Sweden involved in this evaluation. And the team that I'm representing from Jönköping University had responsibility for a number of measures in Axis 1, and also the measures on diversification and economic development in Axis 3. So basically, we had responsibility for the type of measures that are directed to firms and that aim at increasing firms' competitiveness and performance. And I will focus exclusively on measure 121 in this presentation. And also, due to brevity, I will only talk about how we answered one of these evaluation questions. So we answered more program-specific and common questions, but I don't have time to go through more than one because we have different methods for all the different questions. But what I will focus on is the direct effects. So how and to what extent. So it's important to read the question, not only how, but also to what extent, how much has the measure contributed to improving the competitiveness of the beneficiaries. And to start with, I will talk more detail about this, but just to give you a background to how we go about to answer this question. The first thing that's important is, of course, the goal here is competitiveness, increasing farmers' competitiveness. So the first question we need to answer is, how do we measure competitiveness? What type of indicators do we use? And we look at economic theory when we formulate our measures. And we have used labor productivity, which we measure as value added per employee. We have also used total factor productivity, and I will tell you a bit later how we measure this imprecisely. We have also used other measures, such as number of employees, to try to capture other types of effects which are not connected to productivity. But since here is where we find our results, basically, when we look at productivity, so that's what I will focus on. And also, instead of using the FADN, we use detailed microdata from basically all active firms in Sweden. So for the Swedish case, the FADN covers a very, very small part of all agricultural firms, around 10%. And a lot of the variables are plugged with missing values. So we have chosen to use this data from Statistics Sweden, which I will also describe in detail. So just some of the challenges that were addressed before. You're all very much aware of this, so I won't talk about this so much. But our main problem in this evaluation has been the lack of random assignment of the supports, meaning that the agricultural firms in Sweden that received support through this measure during the subsequent program period, they were all more productive, they were larger, and they were more capital intensive. So it's very clear that support is directed to the best firms, meaning that we cannot do simple mean value comparisons, because the firms that received support, they would of course have been developing better even without the support. So that was a major issue for our choice of method. Other things, what you talked about, these real-world factors, firms can receive different levels of subsidies depending on the size of the investment project, the size of the firm, and so forth. Firms can also receive many investment subsidies through Measure 121 within the same year. They can also receive many other subsidies from other axes in the program. So how is it possible to disentangle the effects of this specific support? It's very difficult. So all of this together will result in a selection bias, the fact that we have heterogeneous treatment effects across levels, across farm types, and we also have interaction effects between different types of supports. So it's not an easy task. And what we want to find, basically, what we are after is as the same as you were after in your presentation. We want to find the counterfactual mean difference in the outcome variable, which in our case is then productivity. So we want to find the average treatment effect on treated. And this is just a formal expression of what we are looking for, where y-indexed I stands for the outcome variable. And if it's a 1 in parentheses, it just means that this is the support receiving firm, and 0 meaning not receiving support. And since we cannot observe the same firm for both situations, then this mean difference will be unobservable, given that we have this type of data that we have. We have non-randomized data, observational data. So the most common solution to this problem is to estimate a control group, just as in the previous presentation. And the purpose would then be these control groups should have as similar as possible distributional characteristics compared to the support or treatment group. And there's been a lot of criticism in the literature towards using propensity score matching techniques in estimating control groups. And for example, the method has been accused for being ad hoc and inefficient. And what this critique really relies on or points at is that this matching technique requires a process, a matching process, in which the user determines the size of the matching solution before actually matching, and then and then checking for balance between the groups after the matching. So it's an iterative process, which is very much determined by the user. And most often, we don't see the results of this iterative process being published. So it's very difficult for the one reading the evaluation to say, is this done by quality, or what was the driver of this matching? It's very difficult to say. So basically, we have chosen a different matching method in our evaluation. So we have chosen to use the recently developed coarsened exact matching method to obtain a control group. And this is basically derived from the exact matching theory, and using the type of data that we have access to is, of course, it's not possible to obtain any exact matching of a control group because you have a lot of continuous variables, which means that you have to have exact values on all of these variables, and that is not possible with any method. you wouldn't obtain enough firms in the control group. But there are a number of advantages with this method compared to the PSM. And the main advantages is that you can control for the imbalance, meaning the heterogeneity between the two groups before you do the matching. Then you do the matching, and then you can compare how much has the balance improved without imposing a lot of assumptions as a user. And you can also should be very transparent in when you show how you have done your matching. So basically, I won't talk so much about the details, but this is just to show you the matching algorithm that is used in this matching technique. And the very nice thing about this method is that it's quite user-friendly also, because it generates weights which you then use in the subsequent regression analysis. So it means that you can take these weights, which reflects how important or how relevant each of the firms are as control firms. So this weight varies from 0 to 1. And you can take this weight with you into your subsequent regression analysis, and any type of model that you can run with weights will work with this matching solution. So what we do is we estimate a fixed effects panel model, including these SEM weights. And doing that is comparable to estimating a difference in difference. So what we have basically is our dependent variable, which is then a measure of productivity indexed IT for the firm and the time period. So our time period of analysis is the program period, or not extending to 2013, but we have 2007 to 2013. And we also want to control for the fact that there might remain bias in our sample even after matching. So we want to include as many of these confounding factors as we can in the subsequent analysis. So we have the I stands for internal factors, the E stands for external factors in model 4 and 5. And then the gamma gives the binary treatment effects, which we test in a first step, and then the raw gives the continuous treatment effect. And in order to estimate the continuous treatment effect, we cannot just put in the size of the subsidy as such in the model, because that is very much correlated to the size of the firm. So what we do is we follow the literature in this field, and we divide the size of the support with the income of the firm. So we normalize the factor, because we don't want to just have a scale effect. We want to have the size of the support in relation to firm total turnover. And there are a number of published papers that use the same approach. So I'm going to talk very little about the hypothesis, but we think it's very important to actually sit down and think, what do we actually expect? How do we expect capital subsidies to affect productivity? Do we expect them to affect them positively, and why? Based upon economic theory. And if you look at theory, the effect is very much ambiguous. It can be positive and it can be negative. And what you will estimate in the end is a net of these two opposing forces. But it's not possible to disentangle where the effect actually comes from. But we can just formulate hypotheses both for and against. And just very briefly, you can just read off the slides, but a negative effect on productivity is the case if firms adjust their investment behavior and realize those investment that grants subsidies, basically if they start to involve in rent-seeking behavior. Also, if they receive so much subsidies in relation to their total income, so that they become less motivated to work efficiently because they are so much reliant on subsidies. So there are a number of arguments, but the effect is ambiguous if you look at theory. So the data that we use firm level data from Statistics Sweden, and I call it a sample, but it is almost a total, the total number of firms that are active. But still we have missing values on some variables, so I look upon it as a sample. So we receive that from Statistics Sweden. Then we have data on the firms that received support through the RDP program. We get that data from the Swedish Board of Agriculture. And then we match these two data sets using identity numbers, and we're able to match around 70% of the granting firms, or the granted firms, because some of them doesn't have identity numbers that matches with the one in the other register. So it's not possible for us to have a 100% match. And then we create a panel that covers agricultural firms over the period 2007 to 2012. So this is a delimitation in our study. We are not able to include all of the program years in the analysis. And this is due to lack of data. We don't have access to the 2013 data, or we didn't have it at the time when we did this. So the dependent variables, as I said, we use two different indicators of productivity. We use labor productivity and total factor productivity, and we estimate it using the Levinson and Petrine approach just as a way to mitigate endogeneity of unobserved productivity effects, basically. And the independent variables that we include. We have a set of internal characteristics describing confounding factors at the level of the firm. We have external characteristics giving the economic environment that these firms are operating in. And then the variables that we are interested in is then first the dummy variable, which equals 1 if the firm has received support, and then the amount of support that they received. So what we find basically, what I report here in the first column is the results from just running a naive mean comparison, so not including these weights that makes the results contrafactual or causal. So that is just a simple fixed effects model without the weights, and the two other columns shows the results including the weights. So what we find, and these results are very robust, we have tried different specifications, and we find that the binary treatment effect is positive and highly significant. So we find if we recalculate these two marginal effects, we would see that we get a marginal effect of around 9%. So firms that are in the treatment group have on average a 10% higher productivity compared to those that didn't receive support. And this is a very plausible result because it reflects that the support receiving firms has made investments that were realized them to, or made it possible for them to increase their productivity. But that's just one part of the picture. What's interesting to see is that this effect is actually nonlinear, meaning that if we look at the size of the support, then this effect is negative. And that's, I think, a very interesting result because it reflects that firms that are large and firms that receive repeatedly large subsidies in relation to their size, that has a negative impact on their productivity. And that's also, one can say that that's also in line with theory, in that it means that the more reliant you become on subsidies as a source of income, the less you want to seek other productive methods. And we try to also look at, to split our sample and see, well, does this result hold for all types of firm sizes, or does it hold across subsectors of the agricultural sector? And we see that it holds for small firms, meaning firms that have one employee. The positive binary effect does not hold for larger firms, which is also very interesting because if you look at, now we don't have the possibility here, I should just say, to split the sample into small, medium, and large. because 85% of the agricultural firms in Sweden have 1 employee. So we are a bit restricted here on how we can split the sample. But we find this result to be robust across subsectors and across firm sizes. And when we estimate it using labor productivity instead of total productivity, we find similar results. So I don't remember if you know if you remember, but what I said initially is also that another challenge is that firms can receive investment support for different types of investments. So you can receive support for doing like physical investments to buy new technology, but you can also receive subsidies to invest in renewable energy. So we were interested to see, does the effect differ if we split and look at so if we try to disentangle the effect like even more. So what we do is that we look only at those subsidies that were granted to renewable energy. And what we find is a very interesting result, because we find that this binary treatment effect is still positive and significant. That's robust, but we don't find a significant negative continuous effect, meaning that the firms that realize investments in renewable energy do that basically for different motives compared to other types of firms. And I think that has an important implication for policy. Another very interesting effect that we wanted to look at closer at is, at what point in time do these effects occur? Do they occur immediately, like the year after you receive the support, or is there a time lag before they kick in? And we find that when we run this model, including lags, we find that the effect occurs at t+4, meaning at around 4 years after you have received the support. At that time, we're able to trace this positive productivity effect. And this is very interesting, because I'm not presenting these results here now, but we have also had other dependent variables, and we don't see the same lag structure there. So if we run it with market share or turnover as dependent variable, we see that that effect comes much earlier and productivity comes much later, which is also very reasonable if you think about it. So lessons and recommendations, but I would like to split these into 2 parts, because, strengths and weaknesses. Well, the strength of this type of method is that you can obtain a better match. You can improve the balance between the treatment group and the control group, and perhaps come a little bit closer to the truth compared to using the PSM or using no matching at all. But for certain, these results will be biased. There's no such thing as a perfect match. So we have to be aware of that and look very carefully at the results. And when we recalculate these into monetary values, we have to have confidence intervals to make sure that there's no single measure or monetary value that can tell you the truth. At least that's our view of it. And the weaknesses, of course, is that it's still very difficult to disentangle the effects of the modernization support, considering that firms can receive support also from other axes. And these methods are still in development, and we have not been able to include, we have tried to include like dummy variables and simple interaction effects, but we didn't find any changes in the results while controlling for other supports that they have received. And not to mention all the supports in the first axis, the single farm payment and all of these payments, which are much, much, much bigger. So it's difficult. Let me see, is this my last one? Yeah, this will be my next last one. So about lessons and recommendations, these can be split into one method part and also a policy part. And I think that what we in the evaluation group has seen quite clearly is that if you assume that these supports are randomly assigned, then you will have results or coefficients that are biased upwards. And we see that this bias can actually be quite large in some cases. And also, if you assume a binary treatment effect, well, that gives you a very small part of the story. And sort of the most important and interesting from a policy point of perspective is when you start to dig into this positive effect to see, is it non-linear, and where does it break, at what point does it become negative, and so forth. And we also see this strong heterogeneity in different levels of support. Yeah, I think I have said most of the things on policy. And to summarize, this negative effect that we find, this negative continuous effects, we can't really say exactly what it indicates. It can be a result of inefficiencies, as I discussed. It can also be a result of rent-seeking behavior, that the largest farms, they basically become experts on seeking these type of subsidies. They know how to do it. It becomes a quite stable source of income for them that they can count for, which then has a negative impact on productivity. And it also indicates that there are dead weights attached to receiving high level, relatively high level, and persistent level of supports. And I think that was it, but I didn't present a lot of summary statistics, but I have them in the appendix if you want to know more about the data. So thank you, that was it.
So I'm Franz Zinabel, and I have one question concerning one of the lessons. Those firms that get larger support are less productive, and this could also be due to the fact that if you make huge investments, you have low productivity during the phase of investment because efforts are necessary to make a big investment, and the increase may show up in 2015 and 2017.
Exactly. That's a very important point, and that's also something that we discuss in the report. But you're absolutely correct.
Hello. I think I'm going to repeat Marily's question from the previous presentation, and I would like to know if you collected stakeholders' perception to formulate hypotheses or to explain some of these results. To explain, for example, the question that was put about the efficiency of the farmers, if they think about the efficiency of investment or not through case studies and other methods, qualitative methods.
So you mean if we talk to any of the farmers? We formulated our hypothesis based on economic theory. But of course, one could also do that. But no, we have focused exclusively on theories.
Hello, I'm Xenophon Kokilas from the Rural Development Program of Greece, the managing authority. And I would like to ask you concerning the time lag you talked about on the impact of labor productivity for farms that were supported during the program period. That what this means that for farms that were supported towards the end of the program period, the whole impact is not included in the ex-post evaluation, because the impact will be will come into effect after the ex-post evaluation report. And I was actually having that question for many other parameters that come into evaluating the program. That generally speaking about the time lag of the effects of the program, of the current programming period and the next or the previous. So what I'm saying is that many programming periods could be overlapping in respect to effects and impacts.
Yeah, that's a very important issue, and I have to say that it's resource delimitations, basically. I mean, we put most of our budget into buying these extremely expensive microdata. Many of us in our project had to work for free, basically, because we had spent all our money on data. So, of course, we would have liked to buy data from 2000 and up to 2012 to get a longer view of the picture, but we were unable to do that. And I think that the results that we find on time lags point at that it's very important to make follow-up studies. And for example, today, now we have access to the 2013 data, but now our budget is over and the evaluation is ended. But it would be very simple for us to rerun our models as data gets accessible. So we will continuously learn more and more about these lags.
Hi, Valentina La Sorella from Crea Italy. You say that, that you spend a lot of money to buy this data, no? Actually, at the beginning of the presentation, you said that you use, instead of FAD data from accountability data network that are not really complete in some kind of variable, this kind of data from Swedish Statistical Institute, no? I was just wondering if you think that this kind of method can be applied with YACS data, that at least are free, can be free, and can be not expensive, like you say.
Absolutely, I think so. The question is, will the results be representative if you only have 10% of the, as we have, of the agricultural firms in your sample? But of course, if you have enough observations, then I'm not really sure, because now when I think about it, it depends on how will you obtain your control group? What type of database will you use to match to your... Yeah. Yeah. I'm not very good at the FADN data set, so I don't know, because it's not representative for us in Sweden, so we can't really use it. But from a method point of view...